Hey everyone, welcome to Manufacturing Hub. It is Vlad and I today, so we're going to go ahead and jump right in because we've already spent 2 hours talking about this. And good news, Vlad and I are somehow even farther apart on just the base concept of what IIoT is. So everyone, welcome to Manufacturing Hub. My name is Dave Griffith. This guy sitting next to me today is Vlad Romanov. We're talking all about IIoT and maybe IIoT realities if we get to it. This is episode 168 on Manufacturing Hub. If you guys are new here, welcome. If you've been here before, welcome back. If you guys are new here, we love to have fun, lively, rowdy conversations. And one of our fun things to do is go pull in your questions and comments and other things from chat. So if you guys are watching on LinkedIn or YouTube, which is where most people watch us, please feel free to go drop highs. Let us know where you're watching from today. Let us know any questions or comments or thoughts that you have as we're going through this. And if you have a good answer to what is IIoT, I think Vlad and I are going to need some help on that. I think we're to the point of at some point we are just going to disagree what IIoT is. But having said that, Vlad, welcome to, I suppose, your own show. Tell everyone how you're doing.
I'm doing good. I think, as you mentioned, we've done a little bit of research for this episode, but ultimately, we have a lot of experience in manufacturing and specifically in industrial automation. So I think whether we disagree or not, I think we can discuss what we're seeing in the field and ultimately add value for the listeners if they're looking to, I guess, embark, whether that's IoT, Industry 4.0, digital transformation, and what have you, in whatever manufacturing capacity that may be. So we have a lot of topics, Dave. I think the fundamental question that needs to be answered is, what is IoT? What is the definition or the best definition we can give? And
Mhm.
I think I guess the difference that we'll do maybe versus the other episodes is we can look at some of the publications in our industry and some of the companies that are, I want to say, fairly large and see what they mean by IoT. And then we can have a discussion briefly back and forth on whether we agree with that definition or not. Are you ready to start with that format?
Let's go ahead and jump into it, Vlad.
All right, so the first definition, and again, the way I guess I've looked at this is I've just searched IoT on Google and I've looked at what showed up at the top when I searched for that term. So the first place is IoT World. So this is a publication that collects different data from CEOs, different companies, and I believe they write white papers and they provide some data to industry leaders to figure out what makes sense in manufacturing. And I think they cover, despite the name, a variety of topics. I looked at some of their other publications on cybersecurity, AI, ML, so on and so forth. That being said, if we talk about IoT and IoT products and ecosystem, so I couldn't find, I guess, an official definition that they put forefront, but I think this is the best web page that I could find that discusses IoT. So let me read through it. So the decision to classify an appliance or an ecosystem as IoT or IoT is not straightforward and depends on its usage context. While both refer to interconnected devices, the IoT primarily refers to commercial environments to improve productivity and users' convenience, and the IIoT refers to the industrial type environments to monitor operation of mechanical appliances, improve their operation processes, minimize the risks of operating outage, reduce the overall cost of maintenance, and more. Understanding these considerations will help you select the most applicable cybersecurity regulation for each commercial or industrial operation. We'll disregard cybersecurity, for the purposes of that discussion, because this is a whole other can of worms. What are your thoughts on the definition that they're proposing, or I guess the paragraph that they're proposing here?
I like the delineation between, I think they said, appliances and ecosystems, or as I like to call them, more like point solutions and ecosystems.
Mhm.
I I think it's generally good, and as we have talked with guests, and as you and I have prepared for this conversation, I have realized that the concept of what is IoT or what is IIoT is even more complex or convoluted than I would have previously considered. Than I would have previously considered in the past. So I would say, kind of to my notes or thoughts on what is IIoT, it is very much along the lines of appliances as opposed to, I mean, what I would generally consider an ecosystem. I don't generally consider ecosystems outside of solutions IIoT. which is, I think, a major point in where you and I kind of experience deviations in this. But having said
Mhm.
that, I think it's about as good of a definition as one gets, especially talking about how it's not straightforward and absolutely depends upon the usage context. What are your thoughts on this, Vlad?
I think generally speaking, it is good. It seems that they don't necessarily bring in maybe the software side, right? So they
Hmm.
talk about it needs to reduce outage, but I think those are outcomes rather than the infrastructure of IoT. And to me,
Hmm.
that's both, the sensors, the PLCs, hubs, but it's also
Hmm.
the software that can collect data, store data, analyze data in some shape, way, or form. So I think they don't mention the software side or very little of it. So that's kind of like my take on this. Moving on maybe to the next one. So I'm not super familiar with this company. I think you've mentioned you've not necessarily heard of them either in the prep call, but they do have a page on, what is IoT, and here's what they're saying. So the industrial Internet of Things is the collection of sensors, instruments, and autonomous devices connected through the internet to industrial applications. This network makes it possible to gather data, carry out analysis, and optimize production, increasing the efficiency and reducing the cost of manufacturing processes and the provision of services. So I think, again, if I can put my opinion first,
Hmm.
is they seem to get into the outcomes before necessarily explaining what it truly is. They
Hmm.
obviously list sensors, instruments, and devices, but again,
Hmm.
I think they ignore sort of like the software piece. And again, we'll talk about maybe that in our own side. But I think it also involves protocols and the software. Thoughts?
I agree. I appreciate again. I don't know the group, which makes it silly, which kind of makes it crazy that you and I are here talking about it. But if you scroll up just a bit, I feel like they had an interesting bold point down into the third paragraph of the difference. They talk about IIoT focuses on increasing safety and efficiency at production sites,
Mhm.
which I think is an interesting delineation, but off the top of my head, I would generally agree that most of the solutions that I see are I suppose safety and efficiency as long as we want to include like visibility of data and or democratizing data into efficiency. I think that that's a fairly good. I think that that's a fairly good definition.
Yeah. Next, we got SAP. So
Okay.
this is a juggernaut in many aspects. That is, for those who are not familiar, in ERP software, and we'll talk about the whole pyramid again. If you're
Hmm.
maybe not fully understanding what that is and how that fits into the whole IoT infrastructure. But anyhow, they say that IoT stands for Industrial Internet of Things. As the name suggests, it refers to the use of Internet of Things technology, connected machine devices, and sensors in industrial applications. When run by a modern ERP, I would assume the link is to themselves. With AI and machine learning capabilities, the data generated by IoT devices can be analyzed and leveraged to improve efficiency, productivity, visibility, and more. IoT networks typically support machine to machine communication and the regular transmission of data between the central system and all IoT integrated devices. So they have I guess, an interesting graphic, which again, depending
Hmm.
on how you interpret this, can be of different flavors. In a
Hmm.
general sense, I guess I like the fact that they bring in a little bit better, a little bit more, which is the software side, like I mentioned before, the data analysis and AI and machine learning. Although I don't think that they are a necessity, right? I think when you start saying an IoT solution or device or platform ecosystem requires AI and ERP and machine learning, I don't think that's the case, but we can certainly debate what fits into those molds. What are your thoughts?
I would agree with your statements. I like their visual. I think it's a good visual as to what it's connected with. On the center of the factory is I would say open to interpretation, but overall I like the visual. I think it's a pretty good definition. I think we're doing a pretty good job starting to round out uh, what most people think of what IoT is.
Yeah. Next we got PDC. So this is a fairly known industrial automation company that offers solutions that allow you to extract data from the industrial space, present data, historize it. So what they're saying is the IoT is a foundational technology for Industry 4.0 initiatives that uses connected smart sensors, actuators, and more to connect your people, products, and processes to power digital transformation. Using industrial IoT platforms, companies connect, monitor, analyze, and act on industrial data in new ways to improve efficiency, maximize revenue growth, reduce costs, and more. I like this definition a lot. I think it makes a lot of sense for me. What are your thoughts?
I think I like it. Um, I I think I like it. I think it's interesting that they describe IIoT as a foundational technology for Industry 4.0. I know you and I have gone back and forth as to, at least over the last 3 years of the show, as to if IIoT is kind of a standalone thing, if it's part of Industry 4.0. I like how they put that there. I like
Hmm.
the concept of the smart sensors and actuators to and more connecting to the people, products, and processes. I think that it's a generally good definition. I think it's a generally good definition for being fairly high level. I think the fact that all of the definitions, there isn't a ton of overlap between even the words we're using in most of these definitions. I think it
Hmm.
goes back to prove the point of perhaps defining what IIoT is even harder than previously considered.
Yeah, I definitely would agree with that.
Mhm,
I look, let's look at two more of these. I think they could be a little bit still redundant. So this is GE Vernova. I'm not sure what that exactly is, but I'm assuming it's their industrial arm in some aspects. So they're saying that the term industrial Internet of Things is pervasive in the context of industry as digital transformation has become a business priority for many. So what is IoT? Also known as Internet of Things, critical assets, advanced predictive and prescriptive analytics, and modern industrial workers. It is the network of a multitude of industrial devices connected by communication technologies that results in systems that can monitor, collect, exchange, analyze, and deliver valuable new insights like never before. These insights can then help drive smarter, faster business decision making for industrial companies. What do you think?
interesting. I think that's pretty good. Why don't you read the last one that we've got, and then we'll go ahead and jump into it.
All right. The IoT is a term used to describe the application of Internet of Things technology in an industrial setting. Well, thank you for that redundant sentence. It encompasses the integration of advanced sensors, software, machinery with internet connectivity to collect, analyze, and act upon vast amount of data. The data-driven approach enables real-time decision-making and predictive analytics, leading to improved operational efficiency, reduced costs, and improved product quality. Yeah. I think they're all to some extent similar. I think they bring in different flavors. I think there's arguments to be had be, between like how much data is vast amount of data, or is it more, little skids that can be monitored easier. And
Mhm,
also I think there's a question of, connected to the internet, it becomes then at which layer, right? Because to me,
mhm,
a sensor can be connected to the internet just like a sensor connected to the PLC that is connected to the internet could also be said to be IoT, right? But that's where, the definition becomes a lot more vague. So let's maybe move on to the next bullet point. I'm going to
mhm.
stop sharing my screen. So we have, what hardware and software in your opinion falls under IoT?
Okay, so I think it is. I guess in my mind, when we talk about IoT, at least on this show, I find that the vast majority of the conversations we're having are with software as a service companies, right? And I feel like we've talked about dozens of them on show. We've talked with people who have been part of these groups, and most of the time it is a sensor, and we'll just call it a sensor because it can be everything from a wearable to a temperature, humidity, environmental sensor to nearly any other type of sensor or camera connected to a piece of hardware that is generally proprietary, and then that piece of proprietary hardware goes and pushes the information up into the cloud, so someone else's internet, and then you can go view the data, and or if it's something like a vibration sensor, it probably runs some amount of analysis on it, and you can see the outcome of that data, right? So I think the vast majority of the conversations we have are on IIoT as a service. I think that we had an interesting series of conversations as well last week with Jane. We might get into it more as to build versus buy, but I think a lot of her comments were for some groups and organizations, IIoT going and building or buying it yourself makes a lot of sense. And a good example that she and I talked about and we brought up is our tank farms, right? So I've worked in some small to medium sized refineries that have 3 to 500 tanks of various different types of raw crude incoming and other processed oil and gas um, outputs. And this group ran into a problem, and the problem was the fact that they had no idea how much were in any of these tanks. And while someone was supposed to go walk it every 24 hours on a fairly regular basis, they would run into issues of, hey, no one has walked it for 3 weeks, and we have gone through the process of overfilling. For these guys, it was especially diesel that they would run into a problem with, and they'd literally have to sell it for pennies on the dollar because they had run out of tank space. So I think when we talk about IIoT, I see kind of two different types of solutions as to we have bought a bunch of smart sensors and other sensors, and we are either piping it directly to the internet or we're pushing it up to a web server and then perhaps down into an MES or ERP or something else, versus we're running almost a second set of systems so that we can go see what is happening on our plant floor, maybe for executives, maybe for our plant floor people, but seemingly a second set of systems.
Mhm. Yeah, and I think that's where maybe like you and I have some differences in
Hmm.
definitions when it comes to like hardware and software, right? Because a lot of, let's say, the initiatives that I ran through,
Hmm.
you go to well, I guess like to illustrate a story, you go to a facility and they have connectivity, let's call it, to the PLC, HMI, and maybe SCADA layers, right? And so that facility to me is not, let's call it, digitally transformed and is not IIoT capable, right? And so
Hmm.
to go by the definition of internet connectivity, for me, that would mean to enable, let's call it, the lower layer data to be made available on internet, but mostly like on a network, right? Like so that to me is what truly matters. For what purpose that data can be used, then there's a good question in the chat. Well, it can be used for a variety of things, but it's not necessarily the act of figuring out those things as part of IoT. IoT just means the data is now available for use by other organizations for whatever reason, and it could
Hmm.
be made through any means necessary, right? And I think I mentioned this to you in our prep call. It could be by using a hub for one of these companies that make it a lot easier to integrate, but it could also mean by connecting a PLC that is, Ethernet capable. And that's not to say
Hmm.
that it's possible to do with any hardware. An example for that would be, very, let's call it, inexpensive PLC lines are not going to talk Ethernet, right? So they're going to
Hmm.
be, let's say, RS-232 or 485 capable. And so to make them talk on Ethernet, you need to have a gateway. But at that point, you're essentially collecting the data from that bottom layer of, let's call it, your OSI pyramid, and you're making
Hmm.
it available, which ultimately is the same result as if you were to deploy sensors that can talk directly over Ethernet or over a hub. So I think that's my kind of like definition on take on IoT. And so for me, in theory, any device, no matter how rudimentary it is, could be transformed in being a device that serves up or consumes the data required for it to be, I guess, an IoT capable device.
And as I've told Vlad, I previous to this conversation had never considered creating an IIoT capable or connected factory. For me, if we were going to have that ability, I would generally call it something else, be it a smart factory or smart manufacturing. I'm not sure what the tangible benefits or otherwise would be to going through the process of connecting all of your PLCs to the internet, probably through some intermediary software, other than to give a whole bunch of people heart attacks that we are in theory exposing our PLCs to the internet. I want to go ask the question that I want to go have the conversation about what Edgar asked because I know Vlad and I will undoubtedly get into both of our sides as we continue. I do want to say for the folks listening in chat, I would love to know your thoughts, or perhaps we would love to know your thoughts as to a basically the question is, would you consider or would you think of an entire factory as IIoT capable or compliant? And from my perspective, what would be the additional tangible benefits of that? I think Vlad and I are coming in looking at completely different views from this, which I think is amazing. Consider the, I don't know, 50 hours he and I have had in conversation about IIoT over the past years. But I want to go ask the question that Edgar asks is, can you correlate IoT or IIoT with predictive maintenance, advanced control, maybe as a universal way to connect hardware, software via, I believe what he's saying is OPC UA. Vlad, I'm going to let you go ahead and answer that first.
So I think, right, like to go back to your comment of what is IoT and the delineation maybe with a smart factory. In my mind,
Mhm,
IoT is the pure, as the name suggests, Internet of Things. It's just the architecture. It
mhm,
is just the capability to collect the data, right? To collect and synthesize data in a way that then can be used for these more tangential initiatives, of which
mhm,
the smart factory is going to specify a bit further, right? So a smart factory is one where I can walk in, I can see the data uh, that is being collected, and that I can make decisions in a way that is more synthesized, right? Versus IIoT is just architecture. So does it correlate with predictive maintenance? Having been, I guess, a maintenance manager in food and bev, I would not say it's not necessarily correlated with predictive maintenance, but it certainly has or can have components of predictive maintenance. But I would not necessarily assume just because someone is deploying a quote unquote IoT architecture or solution that it's going to lead to necessarily predictive maintenance as the first step. It could be something as simple as like OEE metrics, right? And Dave and I talked about, and we'll
mhm,
illustrate this a little bit better, just collecting data of a line and seeing how it is running. Well, you could argue that could be for reporting, that could be
mhm,
for maybe figuring out the bottlenecks. Maybe it can aid in maintenance by you knowing some of those numbers, but not necessarily, right? So just because it is IoT in my mind, it is not predictive maintenance. And then the second portion of, I guess, that sentence is a way to connect via OPC, OPC UA, or OPC DA. In my mind, and again, this is something we can debate, I don't think that the protocols necessarily matter. I think
mhm,
that there's going to be, as we all know, there's a lot of different protocols in industrial automation. You can achieve, in my opinion, very close result, barring some very specific edge cases that we can get into. You can achieve the exact same result via any protocol whatsoever. Of
mhm,
course, then becomes, I think where the question lies is, can you scale that architecture? Can you deploy it across different sites? Can you easily, collect data from, you know, 10 sensors versus
mhm,
10,000 sensors? And that's where you can get into debates where like one protocol is going to be a little bit different than another. There's also the question of latency, right? If you need to be pulling a sensor or even getting the information out of a sensor every millisecond versus you can get it every 5 minutes because the silos that you've mentioned or the tanks that you've mentioned, Dave, the I'm assuming
mhm.
the level doesn't change to a point where you need to know that at a millisecond level.
No.
Well, and if someone comes to you and says like we want like real time data on those like silos, I'd almost question like, well, why, right? Like it's not a question of can you? Yes, you can, and probably one protocol will be better than another, but
Oh.
like whether you're doing that for the right reason is a whole other debate. So, anyways, I think the protocols are less relevant than maybe some people that I think have vested interests in the protocols may seem to imply. That's my general opinion.
Yeah, and I would say to kind of Edgar's point is I certainly see groups coming out with predictive maintenance, especially with predictive maintenance on the IIoT side. You see lots of vibration sensors. You see lots of um, vibration sensors and lots of environmental coming out talking about potential failures of machines or of subparts of machines from lots of motors, lots of bearings is what I typically see, but you could go and extrapolate far beyond that as well, if that's what you'd want. As to the efficacy of that, I don't know. I don't have a ton. I don't have a lot of long-term experience or knowledge on kind of any one of these platforms, other than knowing if we go collect vibration sensors, especially if we have a lot of the same types of machines or blowers or motors, we can, in what I imagine is a fairly short period of time, especially talking lifespans, go through the process of having a good idea of understanding when something is out of normal. And if we want to talk about that as predictive maintenance, then I think we can absolutely get there. As to advanced control, I don't know. The closer we get to control and the closer we get to control of critical products, the more and more hardwired I would want things to be. Um, like machine control, especially. And in my mind, I don't necessarily want that as wireless or through the internet before we come back. So Dave's version of that is probably hold back on the advanced control. Yeah, and so Edgar is talking about for example, valve cavitation. We can absolutely go ahead and measure valve cavitation with vibration sensors, and be able to go ahead and know and understand that. That for me, fairly straightforward for someone smarter than I am when it comes to valve cavitation. Um, Edgar. So I think there are lots of those, and I would go fit that into kind of almost like point applications, solution applications. When it comes to that, I to go maybe more back towards Vlad's point, I still think that we're a fairly far way away from having lots of good preventative maintenance in most cases. And so for most groups, I feel like we have to go figure out preventative maintenance before we get to like specifically predictive maintenance. But I have at least seen case studies of this looks good. And I've had a number of conversations with groups of everything that they're showing me and telling me makes sense, and they've got enough technical experience for me to believe the things that they are showing and that they're showing and telling me.
Yeah, I would say that makes sense, right? And I
Mhm.
think you would have to really get into specific examples, and at that stage, again, obviously, we're throwing the term IIoT very loosely. You would have to really look at what's the instrumentation currently being used for, let's call it that facility, and identify. Well, I guess the challenge is what sensing mechanism can you use to detect that issue, whether that's in the process, in the equipment, and like predictive maintenance, I think is a highly complex topic. So I would be
Mhm.
very careful in saying that, again, just because you've connected sensors in a general way, that would lead to predictive maintenance in a specific facility, right? You'd really
Mhm.
need to understand like what the issues are. You need to create maybe like a map, and then like IoT, I think is just enabler. Hey, that's how we're going to collect data. That's how we're going to process the data, and maybe that's how we're going to adjust certain control parameters. Again, that's a whole other. I think there's a lot of considerations there too, but I would not make that the default before knowing the application at a fairly deep level, if that makes sense. Let's move along. I think we mentioned a little bit on the protocol side. Dave, like, do you have any thoughts maybe on which protocols would you, let's call it, label as IIoT more, or are you of the same opinion that it doesn't necessarily matter, or they're all part of the IoT infrastructure?
I think that they matter to some people. I think that they matter to some people, and I think that there are certainly some very specific applications in which having lower data volume, as I've seen kind of studies via MQTT and Sparkplug-B, I think that could absolutely be of value if you're trying to send lots of data and information over cellular networks. So I think to some extent they could, in very application specific instances, be important. Beyond that, I think it's just a function of experience, what the group or organization currently has, and kind of function of cost, right? So
Mhm.
I've worked with a couple of groups who have what I think we would all generally define as IIoT solutions. And they needed to significantly reduce their cost per hardware unit because they were trying to go into a super competitive market. And they used LoRaN, which is not something that I have seen more than a handful of times in industrial environments because it's super inexpensive, right? And so the group that they had bought their stuff from, I believe it was like a Chinese group. It was certainly an Asian group, and they had like a central hub and like 4 or 5 sensors, and you could get that for like $400 or $500. The last time I looked at costing, and in my mind, it's like nearly impossible to go get that for the vast majority of other protocols. So I've seen LoRaN used, especially on lower cost um, lower cost applications and opportunities. But I'd say beyond that, other than outside of a couple of kind of like specific meets our needs or requirements, I find protocols is not something that I am gonna get super deep into the weeds with most groups. At least the vast majority of groups I work with, if they've decided to go the MQTT route, they've made that decision before I go have those conversations with them. Or if they are an OPC UA group, they have OPC UA servers that, I don't know, maybe not quite as old as I am, but it's are 10 or 20 years old, and this is what they use. And so I am generally going to go try to use the correct protocols so that the groups are technically as competent as possible and don't have to go learn new pieces of technology.
Mhm.
Um, yeah, I would make kind of one other comment because on the list, Vlad and I have put together. We included IO-Link, right? And so IO-Link, I think of that as kind of like super base. And what I have found, because we've been having more and more conversations with IO-Link in the last couple of years, I think on the show, is I think IO-Link is great, but it generally costs more money than I'll just call it a non-smart sensor. Like, so if you're going to go spend the money to go buy IO-Link capable sensors, make sure you're going to use what you get on the IO-Link side. Yes, make sure you're going to use what you get on the IO-Link side for scaling or for other purposes. If you use it, it is, in my experience, worth it value wise. But if you're not going to go use it, then you're going to spend additional tens of dollars for an IO-Link capable sensor that you could have just gone and bought any sensor if you're not going to use what the IO-Link gives you value wise. Your
Yeah,
thoughts on
plus you need
protocols, Vlad?
I have many thoughts. Many thoughts. I'll make the comments. So the LoRa network or the LoRa network,
Yeah.
it's also used in home automation and a few other things that I know of.
Hmm.
It's an interesting protocol because it's essentially a low bandwidth wireless network. So it's good for long range, but obviously the amount of data you can pass is going to be limited, right? So this is not something you can probably do in high speed production, but
Yep.
if you need the range and you don't care about collecting the data at a millisecond rate, then
Yeah.
it's good. And you can buy, like, similar to Zigbee, it is a mesh defined
Hmm.
networks, and like you said, it's very inexpensive because I think it's just not as widespread even in consumer electronics. So my biggest debate, right, and my biggest kind of concern of when people try to have the debate between MQTT and OPC UA or DA, and I think the biggest argument is that one is, a server client where you need to poll for data, and the other one is going to be, you report by exception. So whenever something changes, you automatically send that data to the server, right? And we can
Mhm.
here, I think we can go into the Miro board and
Oh, okay.
whiteboard this thing like a little bit, just to kind of explain it in a way. So on the MQTT side, right? So
Mhm.
you obviously also have a server and a client. So let's
Mhm.
call it, well, there it's broker,
Broker, yeah.
and you have multiple clients. So client,
Yeah.
we'll put that as, client. There's going to be duplicates of these. Let me delete that. And so what happens is, the clients are obviously connected to the broker,
Mhm.
and it could be bi-directional, so the client can receive, or I guess like read the information from the broker. But
Mhm.
ultimately, what happens in this architecture is the clients, whenever something changes in the value, are going to publish that information to the broker. Right. Well, the problem here is, well, there's a couple of, I guess, like problems or challenges. They're not necessarily problems. It depends on what you're trying to do. Well, if you have a sensor, right? Like, so let's look at an analog sensor. Analog sensor.
Mhm.
Well, it depends what the resolution of the data is, and what that impacts is how much data it's going to send through, let's call it the MQTT client. And again, so this could be running on either on a PLC or a hub or an IPC, right? It doesn't necessarily like illustrate the hardware, but let's say the sensor is going to be a level sensor, right, for your like grain silos or tanks or whatever. And so, for example, it's set from 0 to 100%, right? And so if someone configures that sensor and they set the accuracy to be on a percentage level, then it's going to be fine. So once this reaches 1%, it's going to send us data that's going to be in the broker, right? Then it goes to 2%, it goes to the broker, so on and so forth. So if your tank is not changing that frequently, this is
Mhm.
perfect, right? A lot of times what's going to happen is this thing is going to be set at the milli milli percentage. So what that means is it goes to 0.00 or 0.1%, it sends the data to the broker. It goes to 0.02%, it sends
Yeah.
the data. And so I guess you're seeing where I'm going with this. Well, if you're going to be constantly bombarding your server or your broker with data that is being updated, then you're not necessarily going to scale this really easily. So I think that
Mhm.
when people start talking about MQTT, it is great, it is lightweight, but there is, how to say it, like some necessity to set this up versus
Mhm.
here's, the other architecture. And again, like OPC. And this again, I'm not saying that either protocol is either better or worse. I'm just
Yeah.
saying there's different configurations that you need to do in order to make sure that you're getting what you're looking to get
Mhm.
in either case. So let's say that you have an OPC UA, or again like DA, doesn't matter much, client, and you have the same, like sensor, and the client is getting the data from the analog sensor. Well, here you can configure that your server is going to retrieve data, let's call it once a minute, right? And so, is your silo or is your level going to change enough every minute for you to care about the data that's inside? And in general, let's say for that application, no. So if you pull it once a minute, it's perfectly reasonable, and you can, look at your chart and it's going to be good enough for that application. So what I'm trying to get
Mhm.
at is you can use either protocol, but the nuances are going to be different, right? On this one, you're going to run into issues if you're trying to pass data that is, let's call it uncondensed. And in this case, you're going to lose resolution if you're polling on an interval that is important to you, right? And so, how do you mitigate that? Well, you can create control structures, or I guess you can build in algorithms to almost combine the two, where let's say on the client side you could collect all of this data at any frequency you'd like or at any delta you'd like, and then you package that and send all of that every minute to then, process at the server level. And the same exact principle can be achieved with an MQTT broker or client. So my whole point here is that depending on the application, you might choose one or the other, and then you're going to have to program in contingencies to handle the data for what you need for that specific application. Does that make sense?
I think it makes sense, and I think at the end of the day, it all comes down to scaling, right?
Mhm.
I think you could go and it really depends upon how quickly you need to go through the process of updating, and the latency and kind of all of these other conversations. If you need to really know the 1/100ths of a percentage of change on an analog sensor, then you need super real time. When it comes to scaling, right? Like if you're going to scale
Yes.
to the milli, then you need super real time, and going and having one or some number of those sensors on an MQTT versus on an OPC broker, it's not going to particularly matter. I think
Right.
what I see is lots of people leaving it on that milli, or just unscale or
Yep.
just putting a non-scaled sensor in, and that causing more problems. I think if it needs to go change on the millisecond, it doesn't matter if it's an MQTT broker or if it's an OPC server. Those are going to, I mean, assuming it's set up correctly, they're going to go hit the server at the same amount of time and time intervals, right? Like
Mhm.
if it gets down to the thousand or the hundredths of a percent on an MQTT broker, and the tank moves in at any kind of amount, you're not going to be able to scale the OPCUA server at a minute, right, or every 5 minutes. You're going to need higher latency than that. I think it gets down again into scaling, which is probably not. I imagine Vlad and I are going to agree on the importance of understanding how quickly you need the data and making sure that you're completely set up. I know Vlad has worked in a bunch of super high speed environments where he wants the information at a millisecond or 5 milliseconds, where I find lots of environments I work on, I see people pegging servers at 100 milliseconds when things change once every 5 to 20 seconds, and we don't need to go ahead and do that. So I think Vlad and I are going to agree understanding and knowing scaling is important. It just really depends upon the environment. And if you're working in a high speed environment, making sure that you have chosen and built solutions that allow you to go peg everything you need at 5 milliseconds. And if you're working in a much slower speed environment, you're going to save a bunch of time and money by just scaling the latency properly.
Yes, and that's all. That is an extremely important consideration, right?
Yes.
To expand on that a little bit, right? So I worked at a site that was, let's call it, as fast as almost the human eye could see. In some
Hmm.
instances, you would need high speed cameras to be able to see the product and be able to figure out mostly like mechanical issues and setup issues. And those high speed cameras typically would be, $100,000 with like four
Hmm.
cameras pointing in one direction. So that's where, that latency mattered. But it only
Hmm.
mattered, right, in very specific instances. Again, when you're troubleshooting equipment, I'll give you like one instance. If you have an over torque on a servo drive, if you're
Hmm.
not trending at the millisecond level at that specific time, and you're only collecting data, let's call it every even 200 milliseconds or every minute, like it was done via the
Oh yeah.
historian at the site, like it is impossible to tell what the issue was, what the tags were prior to that incident. And of course, that data is still usable. You can collect, for example, if you have a register of how many, let's call it, products have been made on that specific machine, you store them in a register and you can pull it every 5 minutes. It doesn't really
Hmm.
matter, right? you're just
Yep.
you're just collecting a number that's going to update during that period, but you only collect that information, you extrapolate as a linear process what
Hmm.
it was at any period of time. And you don't need that information if you're going to look at a weekly report of OE or how many products have been made. It doesn't really matter, which is why
Hmm.
it makes me laugh. There's a statement, I can't remember where I read this or I listened to this, is people would ask for real-time data, right? Because they're like, everyone wants real-time data. And it's
Hmm.
like, what do you want it for? Well, we need it for our weekly reports,
Yep.
right? And that's that is funny, and this goes back again to
Mhm.
these protocols where a lot of people are very, I feel, fixated on how you get the data, but they don't really think how they're going to use the data, in which case, again, you can adopt, I think, most of the solutions to their use case, and it doesn't necessarily matter to have those constraints that you would in those very specific environments.
Absolutely. And I have dealt with a significantly smaller number of super high speed solutions where if you're not collecting 50 milliseconds or 10 milliseconds, you're going to miss the entire thing, right? But the
Mhm.
vast majority of scaling that I see is actually on the opposite side of we think we need real time at 50 or 100 milliseconds, and we can literally walk the line faster than the line is moving. And every time it hits a gate or an interlock, it literally stops and pauses for 2 seconds before it continues. And that is just the entirety of the process, and we're collecting at 50 or 100 milliseconds, and we could really be collecting it a second or 5 seconds in most of these cases and still not slow down the
Yep.
line at all. And so that is back to the scaling point of sometimes it's important to be able to go collect the data really fast. Most of the time, if you haven't created and spent the extra hundreds of thousands or millions of dollars on a system that will allow you to go collect and run while collecting super high speeds, you're going to run into huge issues and shut your line down because your network and your system are not designed for high speed collections. And basically, the conversation I have with most people is if you have a system that is up and running, you'll know if you need high speed collection. Like you probably have high speed sensors and servers and software that's sitting off to the side of the line, and it might just be running in one or two sections of the line, and you've spent hundreds of thousands or millions of dollars on just these sections because you have to have the high speed data collection, whereas the rest of it you don't need high speed data collection, and it doesn't matter nearly as much. And so it may be bad for someone who is in the middle, but generally, if you need it, you know you need it on the high speed data side. And I think it's always interesting because Vlad is always we must go collect data at the millisecond level, and I'm like Vlad. I can't tell you how many groups I've worked with that want to go collect it at 100 milliseconds or 500 milliseconds, and I'm like, yeah, we can go collect this temperature environmental data at 5 minutes or even an hour, as long as we know as long as we know we've got a heartbeat on a lot of these things, it doesn't matter nearly as much.
Well, I think like look, two comments to that maybe. So there's
Mhm.
a big difference between collecting high speed data and
Yes.
real time data, right? I think the only reason why you'd want real time is if you want to make control system decisions or
Mhm.
adjustments in real time, right? What that
Yeah.
means is like your PID loops. Well, if you're running some, let's call it fancy PID loops, meaning that you collect data,
Yeah.
you do some processing on that data, and then you adjust parameters of your process. That's when you need the real time, but that doesn't necessarily mean that it's high speed, right? To me, high speed is, again, it's the speed at which you or I guess like the time intervals. So what you can
Hmm.
have as an example is you can have an edge device that collects every 1 millisecond,
Hmm.
but then it dumps all of that data, let's call it once every 24 hours, right? So it is high speed, but it is not real time in the sense that, like, I don't
Hmm.
need, like, let's say the servo example that I gave, it does not need to be real time because I'm not going to be reacting to the servo crashing and burning at the millisecond that that it
Yes.
happens. I'm going to look
Hmm.
at that data. Let's say if that happens overnight, I'm going to look at it tomorrow. But it
Yep.
needs to be sampled at a high speed rate in the sense that if it doesn't have that resolution, I'm
Hmm.
unable to see what happened prior to that crash. Does that make sense?
I would agree with that, but that goes back to the debate that is even harder, an even harder definition than IIoT, as we've proved at the beginning of this, is what is real time?
Well, like I said, like real time is it's something that you're gonna act on immediately, and real
Mhm.
time in terms of like time means different things. Let's say in the
Mhm.
software or IT worlds than it means in OT.
Yep.
And to you, like you mentioned, if you have like very slow moving lines, real time could just mean if you detect something with a quality system, you capture that data and you need to, let's call it something as simple as like reject or accept or, redirect to maybe like a different station.
Hmm.
Real time could mean, 100 milliseconds to like maybe that takes like 2 minutes on the conveyor to get there. But
Yeah.
that is, let's call it a real time control system for that process. But then like real time could be like beyond that. Like I said, if you have a servo control loop that
Hmm.
needs to readjust the film, it needs to be like constant, right? It needs to be coming in every like 10 milliseconds in some of the applications that I've seen. So it is a constant control loop of 10 milliseconds of readjusting the position. So I think it depends on the industry and your application.
I would agree. I would say, from my experience, most of the quote unquote real time conversations that I have are with executives who want the data, right? Like their screen in quote unquote real
Yep.
time, to the
Sure.
fact of, if we update once a minute or once every 5 minutes or even 15 minutes, that is probably faster than most of them are expecting real time. I find that most of
Yeah.
those conversations, if we want it in real time, basically just means I don't want my data to be stale. I would like it better or more than once a morning in our daily meetings and stand-ups, if I can have it faster than that. So again, if I can get it multiple times an hour, that is real time when it comes to a lot of that. And again, I find those real time conversations and what is real time is dependent on a bunch of things, especially who is looking at the dashboard. I find that most of the time, real time, um, it's a different conversation when you come to like real time control. I feel like we all have an expectation of milliseconds of real time control from our PLC, as opposed to real time for dashboards and data.
Yeah, and that's a very good point too, because again, those dashboards, the way you've described the architecture on the IT side, like 30 seconds of an update of a, let's call it a web app with new
Yeah.
data, that's perfectly reasonable, right? And that's
Yes.
fairly easy to achieve because you can, again, you can bundle the data at the, let's call it
Hmm.
edge level, and then you could send that as a packet fairly easily. Versus if someone takes that literally and he's going to start pinning the server at the millisecond level, it becomes a lot more problematic, right? And that's
Yes.
where I think like inexperienced groups will run into very strange costs, again, depending on how it's set up, or just bottlenecks on, the hardware. They're going to need very beefy, let's call it edge devices if they're trying to do it at the millisecond level for that specific application where it's not really needed. I think there's also a misunderstanding, I think, when people make those requests and maybe the groups that execute what exactly are the details of that integration, right? So if Vlad needs that millisecond data to troubleshoot servo drives, that doesn't necessarily mean that the executives looking at, MES or ERP level data need the same level of granularity. And I think groups run into trouble by bundling all of that together. And so now it's either all data is pulled every 5 minutes or all data is pulled every 5 milliseconds. And so, you know what I mean? Like there's kind of like a
Hmm.
one size solution that doesn't work extremely well for both groups. Does that make
Agreed.
sense? Mhm.
Yes, I agree. Edgar has a comment in here talking about digital twins. I'm going to go ahead and pop this up. So for people tuning in right now, Edgar was earlier asking about predictive and IID for predictive maintenance, and so he wants to know if you see a benefit of digital twin idea as a way to breach or broach the conversation around predictive. And then also on the operational aspect, since we're talking about efficiency. Vlad, I'll let you go ahead and kind of throw your thoughts in. I know that you and I have interesting, maybe even similar thoughts in regards to digital twins.
Yeah, so look, I mean, digital twin is an entire discussion in of
Mhm.
itself. I think there's a lot to be said as to what state we're currently in, and by that I mean what is really tangibly available to manufacturers. I've certainly seen a lot of demos. I have seen some use cases of digital twin for very, I want to say, like niche applications. I think that
Yep.
replicating entire production lines to a level that, how do I say it, like yields very predictable. And I think the challenge, I guess, like to take a step back, I think the
Mhm.
challenge is more modeling sort of the process and the mechanical aspects of a production line. I think it's very difficult to do that with just data, right? So what I've seen groups
Mhm.
do is they would spend a lot of money trying to understand how the interactions of a specific process work, and they would create a, let's call it, digital simulation or digital twin of the process to see what can be adjusted to make the process better. But it was less so of an exercise of just using data. It was more so of an exercise of sort of like process and material transformation than anything else. I think we'll get to a point where you can draw better decisions from, let's call it, a digital representation of a line or a process. But I think we still have a lot of ways to go before that is highly beneficial. Let's put it that way. I've seen basic demos, but not, entire facilities being simulated, and it could be different, in industries that I'm less familiar with. So don't
Mhm.
fully take my word as on digital twins not being extremely useful thus far.
I think that to kind of add to Vlad's comments, I think that most of the successes that I have seen and heard about are in automotive, and automotive, especially like big three style automotive big facilities, is not something that neither Vlad nor I have any significant amount of experience in, especially talking about kind of that higher level. Right. So that is not something that either of us have had experience in, and because we haven't had experience in, I think that's where we see lots of the benefits of digital twins, as the big automotive companies have had a lot of money and are some of the earliest adopters. To my understanding, I've seen and talked with some solutions for smaller, less than 100% of the factory. I think it's interesting, right? Like I will tell you guys what I tell everyone. I think it's really interesting. I would love the opportunity to go find work to work with more groups looking to build digital twins and find efficacy in going and building and expanding that out. But both the operational standpoint and from the digital twin for predictive standpoint, my to summarize my thoughts, I think it's got a bunch of very interesting opportunities. I just don't see, I don't have the experience, and I know Vlad doesn't have the experience to go ahead and say yes we love it or no we don't love it. I do know a lot of people very excited about it, and just based upon the technical competence of the folks that Vlad and I know who are betting big on digital twin, I have to imagine that we will go ahead and find ways to go ahead and get there. Vlad, we've
Right.
somehow managed to talk for an entire hour on this topic, and I think we're like halfway through the first bullet point that you and I had put together. Um, let's go pick like one more topic to go ahead and dive into today.
Let me
Okay,
let me bring in the questions, I guess, or the comments that Edgar made, because
okay,
so he's saying that the real delay comes from the physical aspect of the process where either electrical or pneumatic control dictates the timing parameters, right? So again, it really depends on the process and the industry, right? So I've illustrated, I guess the example that I gave was a servo motor, which was for a very high speed process. Of
yes,
course, if you're working with liquids or maybe like
hmm
beverage type of equipment, there the, I guess, the rate at which you want to send that information is going to be dictated by other parameters, right? And if you look at the very like fundamental level, if you look at the data sheet of a sensor, I believe that the rate of change is like 40 millisecond. Like that's how long it takes for the circuit to actually convert, let's say, digital to analog signal. And then if you add layers to that on the processing side, in reality, you don't really gain much by pulling that sensor more than, let's call it, that 50 millisecond every single time, right? So there's an argument to be made there. The same goes if you have a pneumatic type of a system. Well, it takes, I think, a valve like a solenoid, a relay, it takes 200 milliseconds to transition. And so that pneumatic, let's call it, cylinder can take up to a second or 2 seconds, depending on how big it is, what the airflow is. So yes, you're not going to gain anything by polling that state every 5 milliseconds when it takes 2 seconds to transition from one state to the other. And so NGET also adds, even when handling flow, does it really matter if the deviation is plus or minus 1% is detected? The PID will readjust the position, but if such changes is not relevant, it will wear out the control device. Yes, it in that specific example and maybe in that specific process, it doesn't matter, right? But I
Mhm,
know in, for example, in oil and gas, that could be a matter of life or death, right? If you have like spikes, if you have big changes, depending on like the
mhm,
gas levels, it needs to be near real time, as we discussed, right? And
mhm,
again, is it going to matter for your specific industry? It doesn't seem like it. But again, I used one example, right? Like servo drives is one
mhm.
example. There's going to be vision systems. There's going to be like quality inspections. Those are also running at a fairly high rate, and usually that's going to be, again, in the millisecond range. And I know a lot of applications, I think, in the aviation industry where you'd be doing inspections quite fast. So there it matters, right? But in the example maybe you're giving, it is not as relevant, which goes back to my point. You need to have the right architecture in place for your industry and your specific application,
Mhm.
because if it doesn't matter, then it should not cost you as much as it would for someone that does, right?
Yeah,
Ultimately, that's what it
I
boils
I
down
would
to.
I would say even to go add, like, resolution of sensors, there's a huge difference in cost of sensor resolution if, 2 to 5% is acceptable versus,
Right.
1/10 of a percent.
Yes.
Yeah, there are huge cost differences. So I think it's interesting, but it is very industry dependent, right?
Yep.
It was Vlad and I were getting ready to talk about this. I was sharing an IIoT application that I looked at. I think it was last year, where it was mostly manual filling on a filler for cosmetics, and they had like virtually no sensors on this almost completely manual process. I don't remember if it had like a pull handle or that was automated on the belt, but they had no external outputs of any of that. And that's basically if we get it above X mark on the cosmetics fill line and we get the cap on, we're fine. If we don't get it above that mark, then we're not fine, and we're generally just going to eyeball it. Maybe we'll put in an extra 5% on average so that we don't have to worry about that. And that's like the exact opposite. I see Edgar says he's in oil and gas, right? Like that is like nearly the exact opposite of oil and gas. But I think it all goes down to cost and applications and everything else.
Yeah, I would definitely agree. And I think we wanted to do an example. I don't know if we'll have time for that, Dave. Let's dive into, so I think it's IoT versus Industry 4.0 versus digital transformation. I think we talked about that a little bit. I think,
Hmm.
if I can throw in a couple of comments
Yeah.
and then let you do that as well. Um, let's call industry 4.0. I think it's the change in how manufacturers are doing things, right? So to me, it was first, it was like coal production, then it was sort of like lines, right? So it was Ford that sort of reinvented how manufacturing is being done, was industry 2, and then industry 3 is essentially extracting data, and industry 4 is being able to draw, an Industry 3 was more like automation, right? Like robotics, sensors, and
Hmm.
PLCs. Industry
Yep.
4 is extracting data, making decisions based on that data, and being able to drive the business as a result of it.
Hmm.
Versus digital transformation, to me, that can mean a very broad array of topics for, I want to say, almost any business, but in the context, let's say, of industrial automation, it's doing something with pen and paper to go into a more digital solution, and that could be either augmenting the workforce, it could be augmenting the process, or it could be augmenting, maybe even like higher levels of your like ERP, MES. So just by, I would say, installing an MES when you don't have one, well, you're digitally transforming, right? Or if you're going from like paperclip collecting data to adding a sensor on the line, where you're technically digitally transforming. So it's a very broad, I think, term used in our industry. And IoT, like we've discussed, I think for me, it's enabling data being flown from the bottom sensors, devices, and obviously back to them, but into the internet or I guess network layer of your model.
Okay. I think for me, IIoT is perhaps an easier way to go ahead and collect data that doesn't include your typical industrial stack, from sensor to PLC and above. And this is where Vlad and I completely diverge in our concept of IoT. But for me, IoT is different ways to go ahead and collect that data. And I forget which of our earlier examples talked about IoT as part of Industry 4.0. I think you gave a generally good kind of definition of Industry 4.0. And I think if we look at IIoT as adders to Industry 4.0 or digital transformation of ways to go collect data, I think that is important. I would generally say that on my side, digital transformation is the look of an organization as a whole, inclusive of any manufacturing or industrial side, but certainly expanding beyond that into all of the perhaps unfun stuff, all of the operational stuff, sales, accounts payable, accounts receivable, et cetera, that we generally don't talk about here.
Mhm.
But it's the look of at an organization as a whole. I guess in my opinion, you have to be an industrial manufacturing group to go through an Industry 4.0 initiative. You could be nearly any sort of group to go through a digital transformation initiative. But at the end of the day, I feel like lots of those are buzzwords that various groups are using. And I find that all of those, how do I say? I find that all of those terms are very dependent upon the organization, right? You can go, and if a group is looking to go through an Industry 4.0 or digital transformation initiative, go around the table, ask everyone what that means to them as an organization. You're going to get 14 different answers off of 12 different people. So it's very dependent, and what, in my opinion, really makes sense is understanding what really matters to the group that you're working with or the group that you are working for or leading. That is the most important definition so that you can make sure that you hit those success variables and everyone is happy.
Yeah, I think that's a really good way to put it. Let's I guess like hit one last bullet point, which is why should we slash why should manufacturers care about IoT, right? And I can start with maybe some examples. I think this is one just in time manufacturing, right? This is a story that I told on stage when we were at SPS.
Mhm.
But ultimately, this small labeling, like this CAN labeling facility, was able through connectivity of their machines from the plant floor into MES and ERP allow customers to essentially automatically schedule production runs without needing to talk to anybody on the plant floor. So, just in time manufacturing, I guess if you're not familiar with the term, it's the ability for the customer to order, let's call it a whatever variety of SKU, and that would be almost immediately put into production instead of the, let's call it the old school way of, you go online, you pick up the phone or you send a fax to create some kind of a batch, and that's going to be put in place and be delivered to you 3 months later. So this is something that's I don't know. I don't want to say like it's common, but one example, I think Apple does this. If you order a custom,
Mhm.
engraved iPad or a Mac, usually it's not a warehouse of those products. It's going to be almost manufactured in order. And again, we can debate on what the delay of the you placing the order versus getting that started to produce is, but it's just a quicker ability to deliver a finished good to the customer than it once was possible, right? So that's the business opportunity or the business value in
If
just in
I
time.
may, the counterpoint for just in time is all of the delays that we saw during the first couple of years of the pandemic. We were just out of things because we didn't
Yes.
have stock of literally anything from finished goods through raw material, including work in progress. So I would say we have seen the downside of that. I think just in time manufacturing was like '90s through kind of mid to late 2000s, 2010s. I think we've seen some groups go away with that and hold more things in stock, because the concept of just in time is not just that we have the Vlad Romanov specific iPad with his name and some funny phrase engraved on the back of that, is, pulled out of the box, engraved, put back in the box, and shipped. It's also the fact that we expect to have every single sub part of those components show up to the warehouse hours before, or maybe we'll go crazy and say a day or two before. So all of our sub assemblies are arriving just before we need them, which means that our sub assembly providers are getting their, components
Mm.
right before we need them, et cetera, et cetera. So it is it's a concept that we've seen people go away from, but you certainly need the information. I would almost say maybe the biggest group that we see that most people would run into is Walmart. They've had a number of just in time, if you will, if you want to use the phrase, kind of case studies that exist of basically things don't show up into to the stores, at least pre-COVID, until like right before they needed to go out, right? They wanted to minimize the amount of stock that they had for any item that they didn't expect to sell at the individual stores, and they wanted to do the same at the distribution centers. So they wanted to own or have ownership of those physical items for the smallest amount of time possible until they make it directly to the shelves.
Mhm. I would say, look, my argument is less so on the, I guess, the issues that can happen as a result of running just in time.
Mhm.
I think it's more so like IIoT is almost a necessity for you to
Oh,
be able to get
absolutely.
that data. Yeah, so I think they're almost like separate problems in my mind, right? If you're going to go ahead and instead of storing like 100 parts, and you're gonna be
Yeah.
like, well, we're gonna store only two of them, and then you run into what happened like during COVID as a result of that. That like that's on you. That's not because you had the data available. That's because you decided
No,
to be
no,
like
that's
extremely
fine.
greedy.
I'm not trying to debate the efficacy of
Right.
just-in-time manufacturing. My comment was more for the listeners of, it is something that we have seen large organizations go to more and more, and it's, I don't want to bash on Vlad and his MBA, but it's one of those MBA terms that we've I'm going to use another one of those terms, leaned out the supply chain as much as possible so that we have the smallest amount of capital humanly possible. And there are downsides of that.
Yes, I would agree. The next item on the list: process optimization slash bottlenecks.
Oh, okay. Vlad is pulling out his MBA. Vlad, how do we not have that? How do you not have that framed?
It was COVID. They ran out of frames.
No, I
Supply
mean,
chain
in the
issues.
last 2 years, how have you not gotten that framed?
Well, I haven't gotten around to it.
For
It's
Vlad's birthday, someone's gonna drive to his house, steal it, and I'll go pay to have it framed.
I wanted this like very super fancy frame that it cost I think like $300, and then they were like out of those frames. It's like a gold embossed like wood frame. But anyways, I'll
Have no appropriate words.
good.
Uh okay, Vlad.
Uh
What are your final thoughts? Do we want to go talk about? So we've talked about predictive maintenance. Thank you, thank you, Edgar. Do we want to talk about compliance or optimization?
I think we talk about process optimization and bottlenecks. What do you think
Thank you,
about
Frank Lamb, for just-in-time frames. The downside, quite personally, for Vlad, for just-in-time. No, but process optimization. So let me go ahead and talk a bit about process optimization. In my experience, having data to back up the thoughts and feelings that the folks on the line have in order to go through process optimizations is really important, right? Like best case scenario, we've got a whole bunch of data collection. We can go even use a tool that is not Microsoft's Excel to go extrapolate that data into understanding where a theoretical bottleneck is on the line. And then once we have that data, we can go through the process of removing that. We'll just use the phrase removing that bottleneck, right? And so that is good and important. What I have found is that most groups that are struggling with process optimization don't have a lot of this data. And so the ability to go put inexpensive sensors or IIoT enabled cameras or other things at the line to go watch what this happens so you don't have to have an intern sitting there for 24 hours a day is exceptionally great. Um, yes, that is kind of my comment of finding cheap and inexpensive ways to go do some of this monitoring before you go look at especially expensive, time consuming process changes or process optimizations.
Yeah, if I can add to that, look, I've certainly worked on a variety of different initiatives of optimization, bottlenecks, process speedups. I would say that they're all very difficult, right? And what I mean by difficult is, again, I think that there's a lot of custom equipment that you need to have very deep understanding of. And if we tie that back to IIoT, you need all the tools you can get to make the most out of that, let's call it optimization initiative. And so the comment that I will make is it becomes not necessarily prohibitively expensive to collect all the data, but you need to be very certain that what you're collecting is going to be used to optimize the process. And I think this is the example that we wanted to give, Dave, where you need to maybe start with something easy to understand, and that may already be there in your production line, which is essentially a breakdown of every machine, and you're trying to understand what the performance of that machine is and ultimately where the bottleneck lies, right? I think that's the most basic way for me to put process optimization and sort of like bottleneck identification. And at that stage, if you are unable to answer the question of how well is each asset performing,
Mhm.
it becomes almost impossible to do anything, right? So almost every first step of, hey, we want to optimize or we want to increase the capacity of this line becomes, well, do we have the data to show what the assets are doing, how available are they, where the bottlenecks are? And so that's where IIoT benefits, where you can, as we discussed a little bit off stream, I can certainly go to the site and figure out a way to hack into the controllers and the current control system if it is available. But the easier way perhaps would be to add some sensors at the infeed, at the discharge, and collect that data for a, I guess, more tangential approach.
I I would generally agree with that. Before I get into that topic, I do want to go show that this Frank has posted a link, and the link is to the request to go ban Excel from the engineering community. To Frank's comment, Frank, I would absolutely love to go do that. I'm just being realistic when I said that hopefully we can use a tool that is not Microsoft's Excel to do this. Sadly, I see lots of people doing lots of work on Microsoft Excel because at the end of the day, most people know how to export a CSV file from the system they're working on and go use Microsoft's Excel. It is not a great business intelligence or manufacturing intelligence tool. It is just something that almost everyone knows how to use. But thank you for that. I have a laugh, and we'll honestly get another laugh when we get off. Vlad posted a frame for all of our podcast listeners. Vlad, you should go drive there because they want to charge $40 and take 4 to 5 weeks to go ship you that frame to your house. Like it is worth driving back to college in order to go pick that thing up. I have no idea how far McGill is, but I cannot imagine it's $40 of petrol away. Having said that, and back to the process optimization topic, I agree. I don't think process optimization is much more difficult than most people give it credit to. And then I would agree going and having the data is important. I will make one like operational excellence comment and leave it at that is that facilities should have a design constraint And if you're looking to go speed things up, you should go look at that design constraint first. If you are a facility that has a filler, your design constraint should be the filler. If you are having issues at places that are not the filler, go fix those issues, because the filler should be designed to run maybe 20% faster than the rest of your line. That is a good place to start if you have a filler. Yeah, that's a good place to start if you have a filler, which I'd imagine a decent percentage of our listeners have. But go look at what is or should be the design constraint if you go have the conversation with the people that you are working with or working for, and they've got no idea what I'm talking about. That should not be a surprise in and of itself, but that is in part why process optimization is difficult, and knowing where and how to go pull the correct levers to optimize the process is a really important skill that very few people have.
I will maybe spoil that a little bit by saying it's the filler because it's where the two processes merge, right? It's where you go from process to discrete in many of
Um,
those instances.
Yeah, but I mean, it's also the filler because the filler in theory is the most expensive part of that process
Right.
and the most critical part of that process, and you don't want things spoiling in your tanks, and that is why we should be able to speed up and slow down conveyors. We should be able to have case packers and other things. We should be able to have case packers and other things speed up and have, quicker capacity to go get through all of that. The filler, and it's easier to go buy faster drives. It's easier to go buy a palletizer or depalletizer that can run faster, or a case packer that can run faster. It is not it is not easy to go replace a filler once you have already got, which again, why it should be the design constraint. Although, depending upon how crazy you Frankensteined your first couple of lines, may not at the end of the day be the design constraint.
Yeah, I would definitely agree. All right, I think it is time for us to wrap this up. I think it was a really good conversation. I think we have left this IIoT definition with more questions than we've maybe provided
Yeah,
answers. I think there's maybe an opportunity for people in our industry or even like end users. I would assume to define it better. But I think it's certainly a worthwhile debate because again, I think it's an important conversation to be had, and the more clarity we get on IoT and a variety of, I want to say, adjointed or closely related topics, the better we will, I guess, benefit in the future as an industry as a whole.
absolutely agreed. This was a fun conversation. You guys will have to let us know if you enjoyed Vlad and I going on, coming to a couple of agreements and maybe more disagreements over the last 90 minutes. It's the some of the fastest 90 minutes I remember this show going so far this year, which generally means that we've always had fun. Hopefully, you guys have had fun too. We'll be back, same time, same place, 4 o'clock East Coast time next Wednesday. I think we're going to have a guest come on. We're going to continue the conversation re IIoT architecture and what that could look like. Thank you, Fran. Thank you, Frank. Thank you, Edgar, for all of the comments and hanging out in chat with us today. It has been a lot of fun. Thank you, everyone else, for coming and joining us as well. If you made it this far, make sure that you guys are connected to Vlad and I and are following Manufacturing Hub Network on LinkedIn, on YouTube, on all of the other places. And if you guys have made it this far on podcast format, thank you all so much. Yeah, thank you all so much. Everyone, remember to do those like and comments and subscribes and rate us 5 stars and all of those other important things that when I remember to ask and Vlad pushes the podcast out, you guys do and more of you guys listen to us, which is really freaking cool. Until next week.